Triangle inequalities. Our objectives in this lesson is to be able to order side lengths of a triangle given angle measures and order angle measures given side lengths. Also to be able to determine whether a triangle can be formed given 3 segment lengths and determine the range for a possible third side length given 2 side lengths. First, let's talk about the relationship between sides of a triangle and opposite angles. Label the shortest side and smallest angle of this triangle to the right. So it is clear that the shortest side of the triangle is side BC. We could take out a ruler and measure it if we needed to, but it's clear that BC is the shortest side. Which is the smallest angle? Well, angle B is obtuse, angles C and A are acute, and of angle A and C, it's clear that angle A is the smallest angle. Let's now label the longest side. The longest side is this side, side AC. How about the largest angle? Well, because these two angles are acute and this one is obtuse, the obtuse angle will be the largest angle, angle B. Notice the relationships between these sides and angles that are the smallest and largest. The shortest side and the smallest angle, notice where they are in relationship to each other. Side BC connects vertices, points B and C. Angle A, which has vertex A, uses point A as the vertex, is not even touching that side. In fact, we would say it's opposite from that side. It's all the way across the triangle. So it's clear that the shortest side is across from the smallest angle. Also, the longest side and the largest angle, notice where they are in relationship to each other. Here's the longest side, and it is across from the largest angle. This side uses points A and C to connect to make the side. This angle uses point B to make its vertex. They don't touch at all. They are opposite from each other. So the longest side is opposite the largest angle, and the shortest side is opposite or across from the smallest angle. It's important to remember that as we move forward to order the sizes of angles and sides. For example, order the angles from smallest to largest. Well, notice it's a little bit harder in this triangle to tell which angle is the smallest and which is the largest. And we don't have angle measures, but what we do have are side lengths. So we're going to start by looking at the lengths of the sides. Which is the shortest between 10, 13, and 14? That's right, 10 is the shortest side. Now when we label the sides, we're going to do it using the vertices or the points that connect the ends of the segments. So UF is the side that is the shortest. Going from smallest to largest, or if we're doing sides, that would be shortest to longest, 13 and then 14. 14 is the longest. So F to N is our longest side. 13 would be the one in the middle, UN. Notice we put the segment hat because the segments are making the sides. Now that we know the sides, we can list the angles in order from smallest to largest. So remember in the previous picture how when we had the shortest side used the letters BC, the smallest angle used the letter that was not a part of that side, because to be across from the triangle, you have to use different points. So back to our problem, if UF makes the side that is the shortest, then the smallest angle will be across from that using a letter that's completely different from what we've used for the side. So angle N has to be the smallest angle. Without even looking at the picture, I can complete the rest. UN makes the side that is in the middle, and the letter left out is F. So F would be across the triangle. It would be in the middle. FN is the longest side. Therefore, the largest angle is going to be the letter we didn't use to make that side. So FN, look across the triangle, U will be the largest angle. Let's take a look at the next example. Order the sides from longest to shortest. Now again, I don't have any side lengths, but I do have some angle measures. Unfortunately, I don't yet have all the angle measures, but we can find that easily because we know that the angle measures in a triangle add up to 180. So let's start by figuring out what that missing angle measure is. 75 plus 59 makes 134, and then 180 minus 134 makes 46. So 46 is that missing angle measure. Now we can start by labeling the angles from largest to smallest. Notice this one is the opposite direction as this. Pay close attention to the directions. So the largest angle is angle A that says 75 degrees. Again, we're going to put the name of the angle, not the measurement that's in the picture. So angle A is the largest. The next largest is angle T. And the smallest number is 46, so angle M is the smallest. Now we can use this order to order the side lengths. If the largest angle is angle A, then the longest side will be the side that uses the other 2 points. Remember, across the triangle is going to be the side that connects the other 2 points, MT in this case. MT, and we put the segment hat. T is in the middle. T is the angle, so across from it will be the other 2 letters, MA. If M is the smallest angle, then it's the other 2 letters that make the smallest or shortest side, AT. And there you have it. You are standing 200 feet from a tall building. The angle of elevation from your feet to the top of the building is 51 degrees as shown in the figure. This is the angle of elevation. If you're standing here, you're looking up towards the top of the building. What can you say about the height of the building? Well, I see I have a right angle here and a 51-degree angle. So at least I can find this angle measure. Using our corollary to the triangle sum theorem, if I already have a right angle, 90 minus 51 will give us this other acute angle in the right triangle. So that would be 39 degrees. This missing angle is 39 degrees. Why is that helpful? Well, because now I know that this 39-degree angle is the smallest angle. So across from it, this 200-foot length, this is the shortest side. So can the height of the building, this length that I'm looking for right here, can this length be 200 feet? No, because 51 is greater than 39, and this is across from the 51-degree angle. So I know that the height must be longer than 200 feet. So what can I say about the height of the building? The height must be longer than 200 feet.